Welcome to the Fast Mode podcast series. I'm Tara Neil, and with me today is Armando Montalvo, CTO of Digital Global Systems, and Alan Pritchard, SVP of Business Development. Okay, Digital Global Systems, DGS, is a leading RF signal detection, identification, classification, and geolocation solution vendor headquartered in Northern Virginia. Armando has an extensive background in technology, leadership, and innovation, having served as a group supervisor and department head at Bell Labs and MPAC's VP Engineering for Navigational Systems, focusing on GPS receivers and systems, chief scientist at Hughes Space and Communication, and as a director and business unit leader of a satellite data communications group. Alan, on the other hand, has worked in a variety of technology enterprises covering wireless, fixed broadband, and optical networking systems, providing a strong technology foundation. He has led entire sales functions, major account teams, global sales engineering teams, and virtually every aspect of the technology sales process. Armando and Alan join us today as part of our exclusive editorial segment on Open RAN. So Armando and Alan, welcome guys. Great to have you on the show today.
Good morning. Good morning.
Good morning. Thank you for having us.
Okay, great. So our first question for today is how important is spectrum optimization in Open RAN? I know that this question probably is going to garner a lot of interest because we often wonder how this works in Open RAN. We know how it works in conventional RAN. Okay, so that's one thing. And then we have the second part of the question. Okay, so we want to know how DGS solutions, which encompass, among others, RF analysis, actionable data extraction, and process optimization, improve spectrum utilization and at the same time enable dynamic spectrum sharing in Open RAN environments.
So I think the idea of spectrum optimization within Open RAN is very important, and I think part of the challenge, and I think there's lots of discussions in the industry around why Open RAN hasn't taken off the way people would have expected or would have liked, or at least some industry participants the way they would have preferred it to move. And there's lots of discussions around kind of the political side of it and vendor lockup and those sort of issues. But I think underneath it all as well, there's also the use cases or the real value that it intended to deliver. And I think one of our premises is that through Open RAN and the standardization of interfaces and the ability to introduce applications more quickly and really generate a lot of innovation in terms of the solutions and applications that can be brought into the RAN, that spectrum optimization is part of that, and really taking spectrum optimization to a much different level than it exists within the current vendor ecosystem. So we're going to talk about as we get through the podcast here, we're going to talk about DGS's solution and how the data that we are able to create and expose to the RAN through a number of different methodologies, and of course Open RAN is one of them that gives us an ability to do that. And I think for us that's the real value here of spectrum optimization or Open RAN, is it gives Open RAN another value that it can use to drive adoption. And it's just been that Open RAN has had a tough time. It's been trying to kind of do the same thing that the locked up vendors do, but do it in a more open environment and hope that there's better economics. And so far that really hasn't driven it as fast as they would have liked. So we see spectrum optimization as a great opportunity for Open RAN to be able to move forward more quickly.
It's not that you have the opportunity for multiple vendors and get multiple sub-components of the RAN given by multiple vendors. It's also the ability to create new techniques, all right, and bring new innovation to the RAN. And with that, all right, is the ability to do some functions of the RAN in software, all right, making it available and easy access to innovate kind of quickly. One of those innovations is the virtual RAN, all right, the ability to set the high radio access network, which is comprised of multiple radios that are not located in a single area. In those cases, all right, spectrum utilization is needed, all right, to properly manage, all right, that new network that is not located nearby, all right, that is get distributed, all right, in different locations that we expect to, that we see a different RF environment, all right. So in those locations, all right, give you the flexibility, all right, to partition the network differently, all right, without having to be geolocated. All right, all the radios are located more or less in the same area. All right, in those conditions, spectrum optimization is a must.
Yeah. So, Ellen, do you want to add to that?
No, I think Armando's he's hit the nail on the head there, right? Which is this flexibility that exists within Open RAN and the ability for it to drive innovation. It really connects with what's needed in terms of spectrum optimization and getting us more towards the concept, or at least the dream, of self-optimizing networks. And that's where we're playing in terms of the data that's needed to be able to make those decisions within an Open RAN context.
Wow. Okay, that's insightful. What about network performance? How do your solutions contribute to Open RAN performance?
Yeah. So um, RAM performance is changing, right? The performance expected our radio asset network is changing, all right, as the user cases and the expectation of what the wireless network is supposed to support, all right? So if you think about it in the previous incarnations of wireless networks, all right, the main problem was to provide a pipe, about a throughput, all right, with a certain reliability. All right, services now are evolving, so that requires more than just providing throughput. It requires multiple services to be done simultaneously, and the services has different requirements. So in order to surprise a performance that is supposed to be, low latency, high reliability, like virtual reality, or to provide services like telemedicine and so forth, so on, all right, the RAN needs to be able to understand, all right, whether or not the RF environment can support those services and the requirements. And those requirements are usually, all right, in many cases, all right, conflicting with respect to each other. All right. So the ability to understand the RF environment, understand how to maximize utilization in the RF environment, the presence of multiple signals, is kind of crucial, all right, to provide optimization of the RAN to support multiple services like it's evolving right now.
Great. Zooming in now on xApps and RApps, can the data sets collected by DGS be leveraged by these xApps and RApps to power advanced data-driven functionalities in the RAN intelligent controller?
Yes. All right. The answer is, kind of simple, yes. All right. The extra information that is collected by the RF awareness, by DGS RF awareness, all right, and that allows spectrum optimization can be easily, all right, integrated as trigger information for X applications or Y applications, depending on whether or not you're performing the RIC or not. And especially can also be used to provide analytics that can be performed in the RIC as well.
And I think maybe this might be a good spot to talk just briefly about the difference between what data the RIC has available to it today versus what information could be provided, because by and large most of the attempts here are leveraging RAN performance data that is coming from coming from the RAN, and there's a lot of information that's discarded in the processes that the RAN goes through to properly condition the information it's receiving to be able to perform its primary functions of supporting a data session or a phone call. In that process, a lot of valuable data is lost, and so we are in a position to be able to provide the RIC with a broader set of information about the environment and a more detailed characterization of those signals that are in the environment. So the combination of that broader information and the better characterization gives or supports, in a simple way, supports better decision making within the RIC.
So, when you say characterization, does it mean like you classify the traffic? Is it like some form of identification?
Yeah, but it's not in the traffic. You need to understand, right? So in network traffic, people think, all right, about the IP traffic, all right, the data traffic, right? Is it a video call? Is it a page? Is it and that's after you decode the protocol, all right? We're trying to do that, all right, not only at the database, but mainly at the signal, all right, in the RF environment. We're trying to understand, identify, and classify the different type of signals that carry the message, all right, within the protocol, all right, so that we understand how the signals interact with each other before you start doing decoding. So you can resolve interference problems, you can resolve prioritization problems, you can resolve whether or not the environment, all right, could support a signal that requires a low latency or a low duty cycle like IoT, all right, much better than at video streaming.
Yeah, so what you're getting into is instead of understanding the payload of the traffic, right, or the traffic itself is certainly interesting, but what to be able to really make informed decisions, you have to understand the characteristics of the underlying signals. And in a lot of cases, what we're talking about is we're talking about interfering signals, intermittent interferers, and signals that are impairing the RAN's ability to perform. And so those are very important to understand. They're becoming much more frequent as the wireless world becomes more congested and contested and just far more complicated. Being able to understand the broader set of signals that are in the environment is critical to being able to, because you can understand if you're trying to go through and make optimizations decisions without understanding these signals, you're going to make the wrong decisions, right? So you're not going to get the full value of an AI-based optimization effort if you don't have a data set that is accurately representing the environment.
I see. That's brilliant because most often we see how traffic classification and how that is used to improve how mobile networks are built and how traffic is managed. But now we are going to the RF layer. And like you rightly pointed out, knowing that and characterizing that, those RF signals is going to pave the way towards better optimization of the spectrum and also for the performance at the RAN level. Okay, so I think, yeah, we have a good understanding now at the spectrum layer. But right now, let's move on and understand a little bit more on the at the industry level. So when we talk about industry, how has Open RAN standardization contributed to DGS's offerings in terms of capabilities and performance?
So the simple thing to make it is as follows, right? In the past, RANs were basically hardware and pretty much close to whoever is the service providers or the network equipment providers, all right? And it was difficult to get information and trying to get extra information, provide extra information to the RAN to increase their performance. The Open RAN did two things. One, it created interfaces between several components of the RAN, the radio unit versus the data unit versus the central unit, all right, and different functions in the RAN, and allow people to provide information, extra technology and extra innovations on how the RAN is operated, all right, by providing software interfaces, all right, rather than providing a hardware that need to be somehow pluged all right, into the radio access network hardware. All right. So that has tremendous values, especially for companies like us and Digital Global Systems. All right, because that allows us to set. If you look at the collect the environment this way and do perform these functions that are not typically performed in the RAN, you can increase the performance of the RAN substantially and allow the ability to optimize the spectrum utilization, but also ability to optimize, all right, the computation and the number of radio units you can support in the RAN. All right, so that has been kind of instrumental in bringing new technologies into the radio access network.
And yeah, Alan, do you want to add to that?
Yeah, I guess I'm just one comment. I think one of the elements of Open RAN that's important to us is that there's certainly an opportunity for us to leverage the standardized interfaces, because when you talk about optimization efforts with the RAN, obviously there's some unique integrations that need to happen with the RAN vendor. So within Open RAN, it gives us an opportunity to sort of integrate once, deploy, and deploy multiple times across more vendors. Now, this has been some of the standardization that's needed has been slow to occur, but at least the intent there is beneficial to a company like us, since it gives us a very clear standardized a platform or set of interfaces to be able to work with.
Interesting. I think, yeah, we have covered quite some topics, and we have one last question for today, which is can you share the dynamism between multi access edge computing MEC and RIC and the respective role of each in Open RAN?
Yeah, so and I think this is one where Armando will certainly be able to fill in a lot of my gaps. But my understanding here, there's certainly an option for us to leverage both. I think the MEC I think has been established as important when we're talking about applications requiring ultra low latency, whereas within the RIC, you can achieve low latency applications or support low latency applications, but the MEC being somewhat preferable if you are looking for a faster interaction. I think I wouldn't say we've been ambivalent between the two in terms of where we want to operate. I think we've had a little bit of a bias towards the MEC, but there's certainly an opportunity for us to leverage both of these platforms, since they're both providing the computational capability that's needed for the solution. So
Yeah, I would like to add that typically, um, there is a threshold, no, in which you said, what do you put in a Mac versus what you put it in a REC, and the threshold depends on are we going to create events that are pre-computed with predetermined solutions, then it can quickly be implemented in the REC. All right, recognized event, all right, and you have a predetermined path of action, all right, to provide feedback for optimization of the RAM parameters and or affect the scheduling, all right, operations. Uh, when you actually don't have a predetermined set of path and you require more computation, in other words, providing, all right, applications that need uh, analysis in the RAM before a RAM can make a decision, all right, then usually those are done mostly in the Mac because you have the capability to have far more computation capabilities, all right, in the Mac that you will have directly in the REC, no? So if you're going to provide a complex situation in which you have multiple services simultaneously with a hierarchy of actions, all right, then usually you tend to do that controlling information for the optimization of the RAM and a Mac rather than a RIC. All right. If you trying to, and there's an issue about latency also, no? If there's an issue that you're trying to do something that you can quickly predetermine a solution that is, if this service it has a priority versus other services, and the RAM should be parameterized to support that service first. Those are quick decisions that you can make, and usually these are done in the REC. All right, get better conduit to do on the REC. So there's a position, in my view, for both, all right, for a Mac and a RIC solution, all right, and it depends on how, whether or not you're providing triggering events or you're providing computational analysis, all right, or information to do analysis, all right, before a decision is made.
Yeah, amazing. These are really good insights that you guys shared. Basically, that's all the questions that we had. Is there anything else that you'd like to discuss, or some of the latest things perhaps that you guys are exploring right now at DGS? Is there anything that you'd like to share?
Yeah, one of the things that is kind of important, I think, all right, in the developing of the RAN and developing of the, using an open RAN architecture is the ability to simultaneously, all right, provide services, optimize services for multiple applications, all right, and that's becoming, very important, all right, not for the traditional public, all right, networks, wireless networks, but it becomes most important for private wireless network in which you have enterprises with multiple critical functions that need to be monitored and performed, all right, simultaneously, all right, that are critical to the operations of the enterprise, which is not typically the same operation as a public wireless network, all right, in which you consider mostly delivering throughput, all right. In these such conditions, all right, the ability to have the Open RAN architecture and the ability to have tools like DGS, all right, tool set to optimize the utilization of the spectrum, optimize performance based on RF environmental conditions. All right, I sort of provide that extra dimensionality, all right, to solve that idea of multiple problems. Now, the carriers and the public networks are trying to do similar thing by using slice networks, all right, by be able to use the slicing and take their public network and slice it depending on different users and the needs of different users. But the problem, it becomes very clearly, is it's not that you can support the needs of one user. Is it when one user have multiple critical operations that need to be performed on services, all right, the RAN, the open RAN is better suited, all right, than the conventional RAN to do so.
Yeah, and I'll just add, and I think it is a very important thing for us to end on. And I think another good example of it is, DGS has been very involved in the ONGO Alliance and the CBRS framework, and we're very supportive of the spectrum sharing approach that's been taken as a first step towards real dynamic spectrum sharing. But it's a good example of what Armando's talking about, because in the current environment, if you were capturing the radar you're already capturing the radar that's coming from the coast, and if you're capturing it and characterizing it, and understanding the nature of those signals, then you wouldn't have to turn off the interfering network. You could adjust the operating parameters of that operating network such that the two signals could coexist. So I think that's an example of what Armando's talking about is that there's a lot of applications in a private wireless perspective where you need to provide mission critical support for a network, but that doesn't mean we need to take a blunt approach to being able to provide that mission critical support. By understanding all the signals in the environment and understanding the nature of the services that are being deployed, you can effectively have those services coexist and give that operator the mission critical service that he needs.
Amazing. It's been a great session. Thank you, Armando and Alan, for joining us and for sharing on the critical role of spectrum optimization and the impact of DGS's solutions on Open RAN.
Thank you for having us, Tara.
Great. Thanks. It's been great, Tara. Thank you.
Okay. And thank you to everyone tuning in. If you want to learn more, visit www.digitalglobalsystems.com and follow us for more updates and insights as we continue to uncover the latest in technology and telecommunications. See you in our next session.